Okay, hello everyone. In this question, we have the magnitude V of t of a uniform magnetic field existing throughout a conducting loop, with the direction of the field given to be perpendicular to the plane of the loop. And we want to rank the 5 regions of the graph according to the magnitude of the induced EMF in the loop greatest first. So this graph, as you can see, it shows the magnetic field magnitude as a function of time. And let's note that the magnetic field here is changing with time, but it's uniform. So let's recall what the word uniform means. This is going to mean that it's the same everywhere, so it doesn't vary with position. Now we want to rank these regions according to the magnitude of the EMF induced, E induced, which you should remember it's equal to minus the change in the magnetic flux as a function of time. And of course we have a negative sign just to indicate that this is opposite in direction to whatever whatever voltage we have or whatever magnetic field we have. Like we said by Lenz's law, the direction of the induced electromotive force is always such that the induced current causes a magnetic field that opposes the change in the flux. So E induced is opposing delta phi. That's why we have the minus sign. Okay, so this is our formula of E induced, the induced electromotive force. Now, if we look at the graph, we can see the change in the magnetic field. How can we relate this to the induced electromotive force? We know that the induced electromotive force is minus delta phi over delta t, with phi being equal to BA cosine theta. Now, this cosine theta is equal to 1. Since theta equals 90, we are told that the direction of the magnetic field is perpendicular to the area. So we are left with phi being equal to B times A, the magnetic field times the area. Now delta phi will then be delta B times A. We know that the area is constant, so we are left with A delta B. So E induced can be written as minus A delta B over delta T. And we will notice that this is actually the slope of the graph. So delta B over delta T, this is the slope of each graph we have here. And then E induced will be corresponding to E induced will be arranged according to the values of the slopes of these lines. And if we look at the different regions, region B has the highest slope. And then we have regions D and E. Okay, second highest slopes. And you can see that in regions A and C, no slope, which means that we have no E induced because there is no change in the magnetic field, so there is no change in the magnetic flux, and thus delta phi is 0, and so E induced will be 0. Same thing here, no slope, so no E induced. And if we're going to arrange these now, we can then write B to be the greatest, then D and E, they have the same slope, and then C and A. So in this question, we were able to rank the magnitude of the induced electromotive force from the graph of the change of the magnetic field with respect to time.